This video is also on section 4.4. It is just a video with more examples. You've already had all of the notes. This is going to go a little more in depth about reducing logs and just give you a little more practice. The two sheets that I'll be using are listed in your class notes, so you can print you off a copy of them if you'd like. Again, this is section 4.4, homework assignment number 27. We're going to take a problem such as natural log of 54 minus natural log of 6 and write this as a single logarithm. Now remember, we're going to use ln because the problem used ln. With the minus, we're going to associate subtraction with division, so we'll have 54 divided by 6, and then we'll want to reduce that. 6 will go into 54 9 times, so the equivalent of this difference is natural log of 6. Alright, our second problem we're going to look at is 1/2 log of a minus log of 2. That would be a logarithm with an understood base 10. So we will have log base a, and we'll bring the 1/2 coefficient up to an exponent. Now remember, with the minus, that takes us into the denominator with a 2. Now I personally would rather have your answer look like that. Another way to write it would be log square root of a, because you know that 1/2 power means square root over 2. Problem number 3, we will have natural log x squared minus 2 natural log square root of x. We just need to do a little rewriting. First of all, we have natural log of x squared minus natural log of x. Now remember, the square root means 1/2, and that's raised to the second power. So that's natural log of x squared minus natural log of x to the 2 over 2 power. Alright, now reduce one more time. 2 over 2 is the same as 1, x to the first. Alright, now let's write this as one log. We have x squared, minus means division, over x. So that's going to simplify down to be natural log x after all of that. Alright, problem number 4. Let's suppose we have natural log of x squared minus 4 minus natural log of x plus 2. That's going to be natural log of x squared minus 4 divided by, that's because of the minus, x plus 2. You know that x squared minus 4 can factor into x plus 2 and x minus 2, and then when we reduce this, the x plus 2's will divide out, and we have natural log of x minus 2. Okay. Problem number 5. Let's suppose we have log of x squared minus 5x minus 14 minus, get this where you can read it, log of x squared minus 4. Now you already see that we have quite a bit here that we're going to need to factor. So we'll have log, we're going to have a division because we have subtraction. The first thing I'm going to do is see, let's see if we can go ahead and factor this trinomial into two binomials. That would be x times x. 7 times 2 would be 14, but that's not going to, that's going to work. 7 times 2 is 14. I looked at my sign wrong, excuse me. I need to get a minus sign, so the minus is going to go with the larger term 7, and the plus is going to go with the 2. Alright, over here, that's what we had above. That's x plus 2 and x minus 2, the difference of two squares. Now you do see that you can factor a term out, so we'll end up with log of x minus 7 over x minus 2, and that would be our final answer. Alright, problem number 6. This is one that we have actually not worked with much in college algebra, the difference of two cubes, so I want to call attention to it. We're going to have log of x cubed minus 8, minus tells me to divide, over x minus 2. Now x cubed minus 8 is the difference of two cubes. I just want to point out that if you'll go to page 28 in your textbook, there's a rule for that, or you can probably remember this. If you're going to factor the difference of cubes, you're going to end up with a binomial times a trinomial. The binomial is when you take the cube root of the first, that would be x. You use the same sign as the middle, that would be negative. Cube root of 8, that would be 2. Now in the trinomial, it's a little bit different here. You're going to square the first term. You're going to change the sign. You're going to multiply those two together. Now don't multiply them by 2, that's another rule. And then square the last. Okay, in the denominator we just have x minus 2. And you see what happens, we lose a term there. So we have log of x squared plus 2x plus 4 for an answer. Okay. I want to look at just a couple more, just as a review. We did these in the last section. Let's just review. What if you have log base a of a to the 8th? Remember, if your base and your argument are the same, your answer is your exponent. Natural log e to the negative t. Remember, this is understood to be base e. If these are the same, my exponent, looked up, my exponent is my answer. Number 3, let's say we have log of 10, 3k. Now remember, if you have no base with an log, it's understood to be 10. Those are the same. My answer is the exponent, 3k. Okay, we haven't worked much with these, but what if you have a 4 as a base raised to a power that's, say, log base 4 of k? So my base is 4 raised to a logarithmic power where my base is also 4. Then my answer is that argument, which is k. Think about it as being the only thing left, and that will get you there every time. E to the natural log of 5. Now remember, this is understood with ln to have a base e. These are the same, so my answer is 5. And I have 10 log 7t as my power. Alright, understood base 10. These are the same, so 7t would be my result. This is just another review to pull some thoughts together.